Hello friends, welcome to JAYANI Academy. Myself Praveen Kumar MB, BE in Electrical and Electronics Engineering. So today let us study about basics of electrical and electronics engineering. Electrical energy is also one form of energy. We have many sources of electrical energy, conventional and non-conventional energy sources. So we have conventional energy sources, non-conventional energy sources. Okay, conventional energy sources. Conventional energy sources are the energy sources which we use conventionally or traditionally or by our regular practice, like hydroelectric power plant, nuclear power plant. So these are the conventional energy sources. Non-conventional energy sources. Non-conventional energy sources are the solar power plant, wind power plant, geothermal energy. So these are the non-conventional energy sources. Conventional energy sources are the non-renewable energy sources. Non-conventional energy sources are the renewable energy sources. So now let us study about what is current, voltage, some electrical parameters. Let us study. Okay, let us see current. Current is the flow of free electrons in a conductor. What are free electrons? So we need to know the atomic structure of an atom. Okay, atom is the smallest element available in the nature. So it has nucleus. Nucleus is having protons and neutrons, and electrons are spinning around it. Okay, so this is the nucleus. The central part of an atom is the nucleus, and electrons will be spinning around the nucleus. So these are the electrons. So the electrons responsible for the flow of current or which carry the current are the outermost orbital electrons. These are the orbitals. So electrons which are revolving at the outermost orbit of an atom are the free electrons. So these are loosely bonded to the nucleus. They can easily flow from one atom to another atom when we apply some force. Okay, so current is the flow of free electrons. Okay, or we can call current as rate of change of charge. Okay, rate of change of charge. Current is equal to Q by T, where Q is the charge, T is the time. Q is the charge and T is the time. And what is charge? Charge is given by number of electrons. Q is equal to N into E. N is the number of electrons, E is the charge of an electron. Charge of an electron is given by 1.6 into 10 raised to minus 19 coulombs. Okay, so charges unit is coulomb and the current's unit is ampere. Current's SI unit is ampere. Okay, and current can also be defined as ratio of voltage and resistance. So current is equal to V by R, amperes. Okay, current is equal to voltage by resistance. So now let us know what is voltage. Voltage. Voltage, we can define voltage as work done per unit charge. So voltage is equal to work done per unit charge, and SI unit of voltage is volts. Okay, and we can define voltage as V is equal to I into R, the product of current and resistance. And what is resistance? Let us know what is resistance. Resistance is the opposition offered by a conductor to the flow of current. Okay, the resistance is the opposition offered by a conductor to the flow of current. Resistance can be given as R is equal to V by I. The ratio of voltage and current is resistance, and resistance can also be given as R is equal to rho L upon A, where rho is the resistivity of the conductor, L is the length of the conductor, A is the area of cross section of the conductor, and resistance SI unit is ohm. The symbol is the Greek letter ohm. So this is about current, voltage and resistance. So let us see Ohm's law. Ohm is a scientist who has given a relation between current, voltage and resistance. Let us see Ohm's law. Consider a resistor of resistance. Resistance is R. This is a battery. This is the current flowing through the conductor. Ohm's law states that current flowing through a conductor is directly proportional to the potential difference or voltage which is applied across the conductor. So we can give an equation. I is directly proportional to V. I is the current, V is the voltage. Or you can write it as V is equal to R into I. R is the proportionality constant, and this is nothing but the resistance of the conductor. So now we can rewrite it as V is equal to I into R. V is equal to I into R. This is also one form of Ohm's law, and we can write I is equal to V by R, and we can write R is equal to V by I. Voltage unit is volts, current unit is ampere, resistance unit is ohm. So Ohm's law states that current flowing in a conductor is directly proportional to the potential difference or voltage applied across the conductor. Now let us see the connection of resistors or the combination of resistors. We can connect resistors in two ways, series and parallel, and also we can connect them in series and parallel combination. So let us see series connection first. Series connection. So if we connect two resistors or any number of resistors in a series, then it is called as series connection. Consider three resistors, R1, R2, R3, R1, R2, R3. Here we have connected all three resistors in series. R1, R2, R3 are the resistors which are connected in series, so that the current flowing in each resistance is same, that is I. If I current is flowing here through the R1 resistor, the same current will flow all the resistors. Okay, this is called as series connection. Series connections. So let us see the equivalent resistance of the series connection, series combination of the resistors. The equivalent resistance or the total resistance of this circuit is known as equivalent resistance or the total resistance when the resistors are connected in series. Now, when current flow, the voltage will drop across each resistors. Voltage drop across R1 is V1, voltage drop across R2 is V2, voltage drop across R3 is V3. Okay. Now the total voltage will be equal to the sum of all these three voltages, that is V is equal to V1 plus V2 plus V3. We know, according to Ohm's law, we know V is equal to I into R. We can write I into R is equal to I into R1 plus I into R2 plus I into R3. Now we can take I common in the right hand side of this equation. Okay, I into R is equal to I of R1 plus R2 plus R3. Now I and I will get cancelled. Now we got R is equal to R1 plus R2 plus R3. This resistance is called as the total resistance or the equivalent resistance of the combination of resistors which are connected in series combination. So R equivalent is equal to R1 plus R2 plus R3. This question has been asked in Dcet 2015 Electronics and Communication branch A2 version. The question number is 178. The question is the equivalent resistance between A and B. They have given the circuit like this. See this circuit. We need to find the equivalent resistance between these two terminals. Means this is a series parallel combination. Okay, how we can solve this? We need to first reduce this parallel combination into a single resistor, right? How will we reduce that? This one we need to find. How can we find that? R1 is equal to, we know when the resistances are connected in parallel, that is R1 R2 divided by R1 plus R2. I have taken that as RP1. The same I will write over here. What is R1? 1. What is R2? 1 divided by R1 plus R2. 1 plus 1. What we got? 1 by 2. What we got? 0.5 ohm. So this value, RP1 value, how much we have got? 0.5 ohms. So RP1 is equal to 0.5 ohms. Now see this circuit. This branch and this branch are connected in parallel. But before that we need to simplify this circuit, because here not one resistor is there. Two resistors are there. Two resistors are there in series, right? We need to simplify this. Okay. What we have found? We have found the equivalent resistance between P and Q. Now we need to add these two because they are in series. When resistors are connected in series, they can be added. So RP1 is 0.5 ohm and another resistance is 0.5 ohm. 0.5 plus 0.5, 1 ohm. So how much resistance we got? 0.5 ohm. Right? 0.5 plus 0.5 ohms. Right? 0.5 plus 0.5. How much we got? 1 ohm. 1 ohm we have got. But another 1 ohm is connected in parallel. Okay. So this is 1 ohm. Again, same. 1 into 1 plus 1 into 1 divided by 1 plus 1. 1 into 1 divided by 1 plus 1 is 0.5. right? So what is our answer? 0.5 ohms. Now let us solve one problem on combination of resistors. This question has been asked in Dcet 2015 EC A3 series. The question number is 151. The question is, when three resistors of values 10 ohm, 100 ohm, 1 kilo ohm are connected in series, the effective resistance is. Question is like this, and the options are like this: 1.1k option 1, option 2 1.11k, option 3 11.1k, option 4 is 0.111k. So let us solve this problem. What they have given, three resistors of values 10 ohm, 100 ohm, 1k are connected in series. So first what we have to do is, we have to write the circuit. See, three resistors are connected in series. Which are they? 10 ohm, 100 ohm, 1 kilo ohm. We have already discussed the equivalent resistance or effective resistance, total resistance, all are same. Okay, we know that when resistors are connected in series, we know the equation R equivalent or R effective, whatever you can write, R effective, R equivalent, both are same. So R1 plus R2 plus R3. Why I have written R3 means three resistors are given. What are the values? 10 ohm plus 100 ohm plus 1 kilo ohm. If you solve this, what we got? 1k plus 100 plus 10, 1.11k. So which option is right over here? Second option is right, 1.11 kilo ohm. So this is the right answer. Now let us move on to the next question. This question has been asked in the same question paper, Dcet 2015 EC A3 series. The question number is 152. Three resistors of resistance 10 ohm, 20 ohm and 30 ohm are connected in series across a supply of 50 volts. The voltage drop across 30 ohm resistance is. So the options are 10 volts, 25 volts, 50 volts and 30 volts. So let us solve this. Before we solve this, we have to write the circuit. Okay, what he has told, these three resistances are connected in series. See here, 10 ohm, 20 ohm, 30 ohm, they are connected in series across the supply of 50 volts. He has given that series across a supply of 50 volts. Okay, we have to write this circuit first. What happens in the series circuit? Current flowing in each resistor is same. Total current in the circuit is same, but voltage will drop across each resistors. I have written over here, V1 is the voltage drop across R1, that is 10 ohm, V2 is the voltage drop across 20 ohm, V3 is the voltage drop across 30 ohm. The question is the voltage drop across 30 ohm resistance. If I need to find the voltage drop across the 30 ohm resistance, I need to know the current, right? I need to find the current flowing through that circuit. According to Ohm's law, V is equal to I into R. I know R, that is 30 ohm, but I need to calculate current flowing through that circuit. How we can find that? Total current I need to find. We have seen the series combination of resistors. Accordingly, I have written this circuit. This is the equivalent circuit for this series combination of resistors. See how it is. This is the R equivalent which is connected across the same voltage supply 50 volts. This combination is converted into R equivalent. R equivalent is equal to R1 plus R2 plus R3 according to the series equivalent resistance. R1 is 10 ohm, R2 is 20 ohm, R3 is 30 ohm. What we got finally? 60 ohm. We got R equivalent is equal to 60 ohm. This series circuit is connected into this equivalent resistance. Now I can easily find out the total current flowing this circuit. The same current will flow through each resistors in this series combination. So now I know R equivalent, I know voltage, right? I know R equivalent, I know voltage. Easily I can find I, the total current which is flowing in the series circuit. According to Ohm's law, I is equal to V by R. What is R over here? R equivalent. We have found this R equivalent. So I is equal to V by R equivalent. V is 50 volts, R equivalent is 60 ohms. So what we got? I is equal to 0.833 amps. Okay. So 0.833 amps is flowing this circuit. This current will be same in each resistors, right? The current flowing through 10 ohm is also 0.833, 20 ohm also 0.833, 30 ohm also 0.833. So easily we can now find the voltage drop across 30 ohm resistance. In the question he has asked the voltage drop across 30 ohm resistance. 30 ohm resistance we know, current we know. Easily we can find the voltage, right? So what according to again Ohm's law, V3 is equal to I into R3. R3 is 30 ohm, right? Right now we have found that 0.833 amps into 30 ohms. So V3 what we got 24.99 volts. In the option it is 25 volts. It is nearer to 25 volts. So which option is right now? The second option is the right answer. 25 volts. The voltage drop across 30 ohm resistance is 25 volts.